Yeah, good. Bowen is in as well. Good. Sangali is badly needed here.
It changed the rules because previously you don't have to be here. You can start the meeting or by yourself. But now I think Zoom changed the rules.
Okay, I reserved the first 15 minutes of this meeting to address the issue Sangali raised on that TokenScript should be designed in a way that every action has its conditions, so that some actions can be hidden and others not. Yeah. Okay, good. So now we are waiting for Brown.
Hello?
We're waiting for Brown.
Hi, James.
Hi,
Wait,
Boo.
I hope you were not talking to me just now, because I didn't catch anything.
No.
No.
Okay.
Maybe it's considered antisocial, but I'm at the office and there's beer here, so I'm having one.
You have a beer already. We start beer thing at 8 o'clock, but you are welcome to start first and have the second beer when we start the first.
Oh shit.
Okay. Brown.
The office is really brilliant during these days. So quiet.
Yeah, I'm thinking pay a visit someday.
I'm supposed to go to the office in Singapore now.
Why?
It's a soft lockdown. Schools are closed.
James, the Android build is not picking up ENS from OpenSea. So I can't see ENS token.
James Brown is not in the meeting room. Are you talking
No.
to James Brown?
No, James Sangali.
Okay.
You are on mute, James.
Hi, James.
Hi, James. Let's look at the first example, James. So this is a link to Karma token. Can you see that?
Can you send on Telegram?
Okay, I just sent it on Zoom, but let me send it again on Telegram. To you, it's privately, right?
Okay, yeah, that works.
Okay. I sent a private message to you on Telegram.
Okay. Okay, just 1 second.
So Boon and Sangali have the link, right?
Yes.
Yep.
Okay, we're looking at line 39. So there is a selection. The ID is expired, and you can see that it's in English it's expired token or expired tokens. That is the name of this selection.
Yes.
And the Chinese version, there's no plural. So where this selection is used, it's used at if you search for expired, and you can find it's not used anywhere. Actually, it's not used anywhere. Okay, that's funny. Anyway, it's written by Sangali, so he probably forgot to use it. Let's look at the other example. Let me send this one, which is entry token. And I'll send a private message to Brown as well. Okay, so entry token, let's look at line 39 as, not 39. Yeah, 39 as well. And there's also expired. Oh yeah, that's where comma expired come from. It's copied from entry token, but maybe in comma case, there's no expired to be used. So that's why it's unused. Okay, so the only working example will be the entry token. Observe line 39. It defined the expired selection and how to display, how to explain that selection. And then you get to see where it is used. It's used in yep, it's used in line 59.
Yes.
Yeah. So this in this action is excludes the expired ticket. You cannot enter the venue with expired ticket. Another example can be observed from XSI. Let me find it. Action XI bridge. Yeah. So I send a private message to Master Brown, and I send a message to everybody in the Zoom. Okay, let's look at XI bridge, where its selection is at line 56. You got a selection there, and line 56.
56. I get TS transaction.
46.
Oh, 46. Yeah. Okay.
And you can see the selection there, and it has a denial message.
Filtered balance.
Not enough balance, and then it is used at the view of which is the view? Oh, it's used at the action on the very top. So you look at the header, line 11. So this action excludes small balance, and small balance is the name of the 46 selection.
Why is it written twice?
Okay, that's because this selection is used as exclusion. So the way we use it, that's actually good point. If you are confused here, other people will be confused here too. We might need a solution for that. So the selection simply defines the selection that is a set of token, and the action referred to it in the header. But in this case, because this is an action token script, and we have no place to put it except in this.
Hey, Babu and James.
Hi, Sunil.
Hey. I just saw that there's James Brown, Bull, and Victor in the call as well.
So small balance and low balance, they should be the same thing, right?
Stopped and came back. Okay. Okay. So let me tell the story of guys. Can you hear me?
Yes.
Yes, I just rejoined the meeting room, so I just need to check. Have you played RPG game like Skyrim or Fallout?
Yes and
Yes.
no.
Okay, good. The no part is irrelevant. So suppose you go to a wooden cabin and you couldn't open the door, then typically there is a story going on there. You might need to get a key somewhere, or if it's darkness sanctuary, then you need to get the code for that. You need to answer 3 questions, which is one of what's the music of life, what's life's greatest what's life's greatest illusion stuff. That's a plot. That's part of the thing that it's discoverable. It's intended that you discover a door you cannot open. Sometimes it's the other way around. That let's say there's a woods, there are trees, there's no path, but if you install download DLC, then there's a path opening for you. So in that case, the option is intentionally hidden, right? So because it's not part of the plot, because there's no plot until you have unless you have downloaded the DLC. So one is kind of denial that is intended to be discovered, and the other is the denial that is not intended to be discovered. Now, mapping this to real life, to the TokenScript story, if you have a ticket, but the ticket has expired, or if you have a certain DAI, but you cannot transfer to X DAI because your balance is below the minimum transferable amount, then this is for something to be discovered. The user will feel nervous if they cannot see the option of converting DAI to X DAI or entering the venue with the expired ticket. They would prefer to have that button there and click that button and get to know that they are not in the right condition to use that function. And that's analog to the wooden cabin. The other is suppose you are the user of Karma token, and some other users are admin users, or that if you start DAO token, then if you are elected as the president, you are able to start a new bill, for example, start a new project to collect people's vote. And start new project button should be hidden if the user is not the president. Instead of displaying the button that for starting a project and gets the message that says you have to be a president to do that, right? So there is a difference where you want to hit the option or you want to make it disabled. Now, both situations exist. So how do we design that in TokenScript? I have a very simple rudimentary design idea that I want to discuss with you. That is, for every action, there are 2 attributes. One is exclude, and the other is available to. And exclude refer to a selection. Available to refer to a selection as well. Except that if you if you hold token and that action is not available to you, that token is not displayed entirely. But if you own a token, however, your token attribute matches the filter in the exclude selection, then you still see the action, but you click it, then you will get corresponding error message that is defined in selection. Make any sense?
I missed the part where if you have a selection, if you have a denial tag, compared to if you have a name tag, what's the difference?
Oh, that is not where the difference is. The difference I want to highlight is whether or not the selection is used as the value for exclude, or is it used for the value of available to. Both exclude and available to are attributes of action. Now, coming back to your message, your thing about denial, that is simply an implementation thing. that if you define the message for denial, and then the selection is used for as a value for exclusion for exclude, then the denial message is displayed.
You mean when the button is tapped on?
Yeah.
When is the denial message displayed?
That is an A. The selection is used as exclude. B. Denial is defined inside that selection.
So if the selection is used for exclude, and it matches that criteria, not enough balance, that action button is hidden, and we show the denial text somewhere. Is that what you're
button
saying?
is displayed, but if you hit that button, you get a pop-up message.
Oh, right. Okay.
Yeah. So the exclude means discoverable. Like normally you should, but now you cannot. And available to means not discoverable.
So if you still use exclude, but instead of denial message, you have a name, what happens if it's excluded?
Simply say not A followed by the name.
Huh? Sorry, I don't follow.
Okay, so your question is, what if the selection is used as exclude, and there is a name defined in it? Then my answer is the message will pop up, says not a, followed by the name.
So like not expired ticket.
Actually,
that's from your second file.
Yeah. Expired is excluded.
Can I just
actually
there's something that's baffling.
Actually, should be yeah.
I'm looking at the xdive bridge. The exclude in the action tag is small balance, and the selection is low balance. Is that?
I think it's meant to be the same.
Yeah.
Is it meant to be the same?
Sorry. Yeah.
Just pretend it's the same.
Yeah. Okay. That's all right. I was just kind of wondering if I wasn't getting something. Okay. Cool. If they're the same, then that makes sense. I can see how that works.
But you see my question about when is name versus denial?
Yeah. Okay. Simply.
Yeah.
The name is simply displayed. Yeah. That's the case. So then you would have the question that why do you have a name and the denial? Why don't you merge them, right?
Yes.
Yeah.
But I can see a reason for it. Yeah. One is if you have a name, you just don't display the action button.
Yeah.
If it's excluded. Whereas for denial, when the user taps on it, they see that message.
Yeah, that
makes sense. Yeah, I like that.
That's my first attempt to design it, but in between, I went to the second attempt, which is to decide this to make the decision based on whether or not it's in the excluded or in the available to. But which one feels natural to you?
Which one
if
is
you want
the
to have both?
Where is the available to example?
There's not.
I'm
sorry.
Okay, got it.
You can imagine one where
yeah, I can imagine it. Yeah, I just wanted to look at it. That's all.
Like cancel ticket, that would be available to only to certain people, right?
Yeah, or reassign, or like I think your DAO one was probably a better one, where only the admin person has rights to begin a vote. Yeah.
Yeah, basically, my first attempt is that if there's no denial, then that means this button should be entirely hidden. But I think that's not clear to some developers. Maybe available to is clear in that case. So what you see is a hybrid Frankenstein. Yeah.
But then I don't understand the difference. Why do you need both?
We don't need both. We just need to decide on one
Okay.
natural to developers. The idea is don't make them think too much.
What about just fail message then? So like if you specify a fail message, then there will be a fail message. If you don't specify it, then the button won't show up.
Yeah, but the word fail is connected to how the transaction failed. Don't want to have a chance to understand it.
All right. Okay.
So,
fair enough.
yeah. So
It's
denial
just
sounds like close the
denial.
door. Find me a better word. I don't like this word either.
Yeah. Okay. Got it.
Well. I have a suggestion for available to though. Do you think include is better? It's more symmetric. Include and exclude. There's a symmetry.
That's an
include and exclude.
Yeah, I know, but the user the developer will think that actually this is a combination, so I can use exclude and include both.
And why not?
Then which one is stronger?
I have no idea.
Yeah, so I don't want them to think about this. I want them to make only one choice. It's like if nothing, then
we don't want to be like JavaScript where there's like loads of different commands to do the same thing.
Yeah, so Apache configuration. In Apache, that is an first you define a rule if it's allow or deny. Then you define the rule if allow is have precedence over deny. Apache configuration, http.conf.
But
that's crazy.
Yes, but you can also read it as available to excluding.
That
right?
means that exclude has a priority.
Yes, that means you are setting an implicit priority.
Yeah, that would work too.
Then include exclude will have the same.
Yeah.
The same solution applies.
Yeah. Okay.
Whereas because of the symmetry, it's easier to understand that it's opposites of each other.
Mm-hmm. Okay, so the best idea so far is available to exclude. Okay, so if you no objection, then I come to the next topic. Okay. Hello.
Yes.
Okay, so the next topic is really quickly that I wish to remove the attribute types container.
Okay.
The reason being that when attribute type is defined inside an action, it doesn't have the container attribute types. But when it's defined inside token, it has. That's inconsistency.
Okay.
Yeah. So better remove both.
Okay.
That's going to be a breaking change. So I'm thinking about implementing this in this schema, which means break Android and iOS. If you hate me for that, I probably will consider and move it to next schema. But such breaking changes, I want to do them early.
Seems like a minor change.
Yeah. So then iOS and Android, are you happy to come up with a change?
I mean, I think also like on a quality of user experience, being able to exclude things will help a lot. Like compound is not, all those kind of token scripts will be a lot better with this kind of feature.
You mean exclude is good, and you are also not against available to exclude.
Yeah, exclude will make all of them better, including compound and ENS as well, because ENS has like some conditional features which you just shouldn't even show to the user if they're not available. It's a waste of time otherwise.
If you think exclude is more important in the beginning, we might consider only doing that and not do available to until, to be cautious not to over design.
Well, yeah, exclude, yeah, would be good. Most valuable.
Okay. Okay. So, so that's it. So next topic is Tor's topic. Thank you very much, Tor, for providing. Hi, hello, you're there?
Yes, I'm here.
Okay, nice. So the topic is how do we start from there? So you mentioned that Presto Presto doesn't have a policy manager. It is supposed to be embedded in another system with policy manager. Do you have any model in mind? What software is your policy manager, or is it not considered and we just have to come up with something?
It's not directly considered. I mean, like what is implemented is basically just sort of a bare bone TLS based web server.
Mm-hmm.
I mean, you can start and you can run, and then, but I mean, it's made in Java using good object-oriented principles, so you can. So I would imagine that the idea is you put something on top of it, like you do a decorator pattern or something like that, where you implement basically a policy of whether the request is okay, and then if it is, you send it on to the actual core, which is gonna handle all the crypto stuff.
Okay, so there's no front-end firewall or policy implication. We just have to come up with something. So what we could do is, Sangali, what are we using right now as a reverse proxy?
Sorry?
What are we using right now as a load balancer and reverse proxy on top of EC2?
Load balancer.
Yeah, the thing that if you send the HTTP request, it receives it and then goes to the backend to get goes to EC2 to fetch it.
Yeah, just regular load balancer.
Or ELB, right?
Yeah, ELB, yeah, elastic, yeah.
Yes. Can you check if it supports policy?
We already put policies in, so yeah.
I mean, policy like how many requests can you make per minute, and how many requests per IP address can you make, and how many requests with the same header can you do? I guess it has, right?
From memory, I remember it being hard to control it at that level because we had that discovery token and I was trying to block IP addresses, but it was tricky. I'll have to refresh on that, yeah. So
if that has policy, we might, because we have fresh knowledge about how ELB works, we can combine that with Pesto. If not, if its policy manager is not very fine, then we need to find something else, maybe Cloudflare or maybe a Java-based one, so that it can integrate on code level. Therefore, yeah. So this is the first thing we check because we are lazy. The first thing we check is ELB. Okay, just find us because what we are trying to do here is to use ELB to prevent brute force attack by keep trying password repeatedly on the same account, on the same Ethereum address.
Yeah.
And just to quick note to Tor, when a user sends password to the Pesto that you are currently having, I guess that the entire thing is a RESTful call, right? Not that the username is part of the address.
Yeah, no, the entire thing is REST.
Yeah, so Sangali, can you also take a note that we need to check if the policy can be built based on the content of the REST call? Because I think they must have policy based on URL, but in case of Presto, the entire thing, both the name and the username password is in the REST call. That means we need to see if it is able to do policy based on the value inside the REST call.
So I remember I wanted to get something from headers inside the server itself, and that was where the trickiness was, because if you called the ELB directly, the IP address and all the headers were set by the ELB itself. So you always got the same IP address. But I need to brush up on that again. I've kept a note. Okay, nice. And Tor, next question is, so basically when the user sets the password for the first time, the user will do 3 consecutive calls to 3 services, and they will do their own negotiation. Is that how it works?
I mean, it's basically like 3 parallel calls.
Yeah. To 3 servers, and then they will be talking to each other per configuration.
Yeah.
And then they will discard the original password.
They will never learn the original password. It's a cryptographic protocol.
Wait,
the servers will never at any point
how does the client pass it to the server then?
Cryptographically, basically. I mean, basically, it's the password is only known by the user, and the servers basically ends up with some shares that sort of loosely based on the password and some randomness in a way where it can be verified, where it can be restored later on. That makes sense. I know it's a bit abstract, but yeah, I mean that's the core of the cryptography in it. Is basically the servers will never have anything based on the password in plain.
Okay, so even when initially configuring the password, the data packet sent to the server is already processed.
Yeah, I mean the client itself is doing some of the cryptography, right? And that's why it's hidden. Basically, it's hidden from the servers.
Yes, that's reasonable. Basically, you have one client, 3 server model, where the client knows the password, do some magic to that password, and then generate the conversation with the 3 servers. And then 3 servers will do conversation with each other and finalize this thing, right?
Yeah, so just so you have an idea, like on an abstract level, it's what's called an oblivious pseudorandom function. It's basically so you know a pseudorandom function, right? You take some some key, you give it as input with some nonce, and then you get a random value out. So basically, the idea of Pesto is to construct a PRF pseudorandom function as a distributed protocol, where basically what you give as input is the username and password, and then the servers contribute with some secret key material, and what comes out is a pseudorandom value to the user. The user then uses this pseudorandom value to generate a public-private key pair and makes a signature and a nonce to authenticate towards the server. So basically, the idea is the server has a public key of the user can use to verify with, and the user never holds the private key. He simply restores it every time by computing the seed, which is the output of this oblivious PRF. So that's the overall idea.
Okay, so if you just look at the communication channel, the user provide a password to the user agent, the client. And the client will inquire 3 nodes and obtain their public key, and this can be attested through a certificate. And then the 3 public keys are in the client side. Clients now have the knowledge of 3 public keys and 1 user password. And then the client will generate 3 pieces of data using this, and then send the service individually.
Yeah.
Okay. So. That's good. That's implementable on Android. What about the SSS part? Like, is it similar that like, or because you mentioned the SSL part doesn't have the client, so now I'm confused. How does it work?
So there's no SSL in this. So basically, like the
SSS.
Yeah. So basically, there's no SSS in this. It needs to be combined, basically.
Yeah, later. Yeah, I know it's a different stage.
And I mean, as I wrote, the semi-secret sharing is basically you can add it as a Maven library. It's just an implementation of the crypto to construct secret share. So basically, you run this library on the client side. You give it some input. It constructs a secret share, and then the client basically sends this to the servers.
So that does that mean the client is the 3rd or 4th party?
Yeah, I mean, you could also, like, if you want to run it in the other way, but by passing it through Alpha Wallet server. But I think
we can make it 4th party just to understand it.
Yeah. I mean, that's definitely what you do. I mean, the client is not gonna hold. I mean, the client is just, sharing his thing. I mean, he necessarily, because he's the one who actually knows the secret at some point. So he's the one cutting it up using the software to cut it up into 3 pieces, and then just piggyback it on the TLS channel you have established with the server after authentication.
I see some work needed so that we can put the SSS component to work in the same way on a high level as the Pesto, because then that makes the interaction unified and easier to debug. basically, that is still the pattern of user provide private key to the user agent, and user agent somehow get some information from 3 nodes, and then with the private key in mind and the information they get from 3 nodes, produce necessary communication to the 3 nodes. Can it be modified into this paradigm?
Could you repeat that again? The client?
So the paradigm in Pesto is user agent is the client. It learns the knows the private key, it knows the password, and first it knows the password and it gets information from 3 nodes, and then it produces the necessary package to send to 3 nodes to start the process. So if we can formulate SSS in the same type of conversation, that will make high-level integration more like understandable and easily debuggable, which means the user agent knows the private key, and then it talks to 3 nodes and gets some information, and then again decide to provide 3 nodes with different information, and that starts the secret sharing.
Okay, see, I mean, basically what you would probably do is, I mean, you know, the client has a certificate of the server, so it can just, you know, it can send an encrypted message, and it can use basically its signing key from Pesto to just sign whatever secret shares it gets, so the servers know that it's the right authentic client that does this. And I mean, then, you know, you piggyback on the security of TLS to ensure that it's encrypted, and then based on the signing key from Pesto, they ensure it's authentic to the specific user, because I mean it's REST, so we don't really have like sessions as such. Or I might be misunderstanding.
See, what we need to do is to get SSS into each of these 3 servers, and provide the high-level function call, like because you mentioned SSS is itself a library. Therefore, I think it doesn't have the RESTful.
No, it doesn't.
Gateway. So somehow this gateway has to be built. And I'm thinking that whether or not they can be built in a similar style as Pesto, so that it's easier to examine if everything is done on a higher level just by just observing the communication, or is it different than that? So sorry, let me step back. If we add a RESTful API gateway for the SSS library, how does it look like?
I wouldn't want to do that. I would not suggest doing that. I would just do it as a flow. I mean, because we only have one thing we want to do with the servers, right? We wanna authenticate. We want to check the user ID. That we want to verify the user that the user knows the password. And then we have the registration where the user supplies the secret key, the secret shares, or we have the reconstruction where the server sends the shares back, right? And I would just use the I would just use the TLS channel already in place to do after authentication to do this kind of communication between the client and the servers.
Okay, so so let me make another attempt. So now I heard what you said. So okay, A, the user agent knows the private key. B, the user agent alone is able to calculate all 3 shares, and they just need to pass this to the nodes. And C, once the nodes have this information, they are able to, in the future, if they want to refresh, they are able to do this only with the 3 shares and no other input.
Yeah. But I mean, again, like the refresh is something that's not implemented in a super way yet. So that's something I would probably, that as we discussed, would leave as a future feature.
Yeah, sorry. Did you say yes to all 3 questions? Because my line just dropped and reconnected.
Yes.
Okay, so now I got it. The understanding is we can create 3 shares on the mobile phone. We can pass these 3 shares as is to 3 nodes. No calculation needed at this stage. They just need to keep them.
Yeah.
And until the recovery or refreshing happens, they just keep them. And when the recovery happens, the 3 nodes talk to each other, and they each provide a piece of information back to the user agent, and user agent is combining them and get the key.
Yeah.
Okay, so
that. And I mean, basically, the communication should be fine to just do on TLS. Like, I mean, the client app basically just I don't know if we use certificate pinning or something like that. I mean, we use some sort of handle on the server, so the client has a TLS certificate of each of the servers, and then it uses that through the REST connection to authenticate itself. And once it's authenticated, like depending on what it want to do, like if it's registration, then it sends the shares to the server after picking a password. And if it's reconstruction, then the server sends back the shares once they have accepted that the user is authenticated.
Yeah, so so for secret sharing, we just use pure TLS as is. But can this thinking be applied to Pesto? Like each Pesto server has a public key. Can that be the TLS key as well?
I mean, if it can be the same, I would say like I mean, I'm not sure I'm following completely now. I mean,
so okay, so let me try to do this again. I'm not being precise. It's my fault. So now I understand that currently understand it is when Pesto is working, and every node has to have a public key, and that public key is needed for the user agent to generate the encrypted, if you would call it, password. So for the user agent need the public key to do some calculation, and that public key is not the same key the user agent establish secure connection with the nodes.
No, it wouldn't be by default.
It wouldn't be. Okay.
Yeah. No.
Yeah. So in case of Pesto, it's needed to somehow deliver that second public key, which is used for calculation, not for encryption, not for securing the channel. And in case of SSS, it's not needed to do so.
Yeah.
And okay, and when the 3 nodes in the Pesto case, when the user agent acquires the 3 public keys from the 3 nodes, they simply trust it as long as the key is passed through TLS.
Yeah, I mean, in that case, you would trust that it comes from the right server. Yeah.
Okay. Okay. So the trust is purely on the connection. There's no need for a certificate.
I mean, implicitly, you verify the server as part of the TLS handshake.
Yeah. Okay.
So in that sense, okay.
Yeah.
I mean,
so
you trust the server.
Yeah. So now I understand how it works. Yeah. 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 Okay. So what we need to do is to take this get the client working, user agent working, and find out if ELB can be our secure policy manager, and that would be the 2 chunks of work. Do you see any other?
You said the what was it? EBLB as policy manager, and what was the other one you said?
ELB as policy manager, and the client user agent with as the the porting the software into the user agent, Android in this case. That's the two pieces of work, right?
Yeah, but I mean, okay, I haven't really done a lot of Android programming, but I mean, this is all it's all Java, right? And so I would imagine that it's not a big issue.
Mm-hmm.
I mean, would imagine here being the keyword.
Yeah, and did I miss any part of the work? We do this two part, and there's a very smaller part which is how to build the TLS connection so that the SSS running on these three nodes is able to keep their share, and that's a small piece of work, I guess, and that should be all the work.
I mean, the servers need some sort of database or do something in any way. Like currently as it is in Pesto, it's just like an imaginary database that implements like a database interface, because I mean the servers need to store something about the user's account. So we would just add that.
Oh yeah, there's another piece of thing. Yes, you're right. So there are three pieces of software. One is the user agent, in this case Alpha Wallet Android. The other piece of software is the node software that runs on each party. And the third is the two-factor authentication gateway, which is deployed by only in one copy by Alpha Wallet. And the policy manager runs on the two-factor authentication thing as well as the three nodes. And the two-factor authentication server has to be written from scratch because it keeps all the Ethereum addresses and their corresponding second factor.
Yeah.
And the nodes are just Pesto somehow with the SSS components in it. And the user agent has to be taken from Pesto as well as the SSS library. And that's the three pieces of work. Actually 4 pieces of work, three pieces of work. The node has to be modified, the user agent, and the gateway, the two-factor gateway. And that would be the work. Okay, so the next thing I wanted to do is to write a specification for the work that has to be done on the two-factor server, as well as the work has to be done on the user agent. And then and then you will have a look at that, and if it's all right, I will probably send the two-factor server thing to an outsourcing team to do it. And then maybe you will be doing the user agent as well as node software. Is that correct?
I think that would be that would probably be the easiest.
Yep. Okay. Okay, that sounds about right. Also, you mentioned you didn't do much Android programming, so maybe it's between James Brown and me to figure out if we can already port the client-side code to Android, and just give us a feeling of how much work is ahead of us as an experimental port.
Yeah,
and that can be done maybe Friday or this weekend. If I talk with James Brown, find out time on that. So that's the output we need to produce as well as the spec. Then we should be able to start, right?
Yeah.
Okay. Yeah. Good. So, yeah. I'm just trying to get a good understanding of what is ahead of us and what is
yeah.
Okay. That's actually everything we need to talk about in this meeting. Anything?
What? I have a question. What are you imagining in regards to database on the server side?
You mean what technology I would use?
Yeah, because currently that's like what we have implemented so far here with the Pesto is agnostic to that. I mean, there's no there's no database backend. There's only like a stop, like a dummy one we've used for testing.
Can we get by with embedded database, because it should be a simple database requirement, right?
Yeah, I mean, I guess it's not going to be that many users. I mean, it's just like a short row for each user, like a user public key and a few log things, and then like shares of.
Yeah. Yes. I'm thinking that so basically it's a key value database, right? Only with the user's identity, in this case Ethereum address, and then a bunch of data blob, right?
Yeah, I mean, if we use the user's Ethereum address as the username, then yes. There's a bit of because the protocol needs some nonce, so there's a bit of that also needs like a box or an element in the database. Like we implemented it with like a time-based nonce that in such a way that we need to store like the last used time to make sure that it's in the future, and it's so there's a little more that needs to be stored in the database, but it's not completely just it's a value key, it's a value key and two other things or something like that.
Yeah, so then you must already have the capacity to store it somewhere for it even to work.
I mean, it's not deployed.
That means you
again,
have to.
It's still like the software here is still under develop. Like the Pester thing is still under development. It's not deployed. It's just we use a database stop, so it's just like in the RAM during testing.
Ah, I see. Yeah. So there's no persistence storage. I see.
Yeah. No, there's no persistent storage.
It depends on if it's one table per key. For every key there is an two-dimensional data, one-dimensional data.
Yeah,
like every
I mean,
key has a few columns, or every key has a table.
Every key has a few columns. That's it.
Yeah, that should be simple.
Yeah.
So what we used to do is to use an embedded. It's a very small embedded SQL database called an H2. And in this case, you don't even need the relational features of it.
Yeah, no.
Yes. Also, that reminds me of the. This is the database James Brown, James Sangali, and me used to use back in the bank. So I think we will be using that, and I need to write that in the spec as well, because that's work. Also, the Ethereum address cannot be the key, because we don't want the adversary to. We don't want someone to hack the system and learn how many data addresses are using secret sharing.
Yeah.
And we cannot use the hash of the address either, because somebody can simply hash all the existing addresses that has many. Yeah. So what we would do is, that the address is the hash of the public key taken the first 20 bytes, right?
Yeah.
So we simply use the rest of the 16 bytes as the key, because that is the knowledge is only available if you have the private key.
Okay. Or I mean, if you see a transaction, and I guess, yeah.
Oh yeah, if you see the transaction, you can still calculate from the signature the public key. Therefore, you can still get that bit of data. Yeah, you're right. That is dead end. Well, I guess then maybe maybe that's it. We just have to protect it.
I mean, we can also just allow the user to pick his own username, right? I mean, the risk is they forget it, or that they use their Ethereum address, but yeah.
Yeah. Yeah. Okay. So that's it. Yeah. The Ethereum address then. Okay. That's a lot to write down later. Certainly we'll have to send it to you and go through with you again, and then we should be ready to go, I guess.
Yeah. So I'm also thinking how, so as I mentioned, like how it is now, Pesto is only done to work in the distributed setting. So I mean, in the sense that all servers need to be part and that you can't use a threshold. So I need to make some changes in. So that's what I wrote you. I looked at, and it's possible to make the change to do while it's still secure. I mean, I haven't done a security proof, but it seems to still be fine to make this change. The reason we didn't do it is because like the way we proved the security of Pesto is in a very strong security model called adaptive security, which we cannot have if we want to do the threshold case. It's not a problem. It's not a problem in practice. It's more like a theoretical modeling thing. So it should be fine. But the point is that I need to. We're gonna end up having two diverging branches from what we're still working on with the Pesto at Alexandria and this project, because it's going to be applied to some partners in Spain for like an EU research project.
Mm-hmm.
And then what we are doing. So I'm just. Do you have any
shared costs between the teams?
Because ideally I would only, it's not going to be that much of the core that changes. It's only a bit of the cryptography in the center, but I would still like to, piggyback on whatever other changes we make around that. Do you have any knowledge of what would be the best way of doing that?
No.
Okay. Fair enough. I'll guess I'll just make a hard copy of what we have and change that at some point to.
You have an engineering need of having the threshold implemented and not available to every fork, right? Not available to every deployment, because some of them.
It's not completely compatible, because some other things I'm going to have to remove some other thing of the implementation that gives this adaptive security. So this means it's going to be different than otherwise than what is the currently is. Yeah. No, I think I'm gonna have to make a hard copy and then.
Sometimes sometimes we do it in two stages. The first stage is to make it ready for that, and that's one branch, and the other is to actually do it. So
yeah.
So therefore, to make the hard copy as less different as possible.
What do you mean? Sorry.
So once you have a hard copy and start to work on that feature, the thing is how easy it is to take the security fixes from upstream. So what we typically do is to simply be very careful and try to stage the changes. Try to for example, threshold that's any changes needed for that is still in the main software, and only the actual changes in the fork, just to make the changes as little as possible.
So I mean, I'll just make a branch of the branch of the same repo, and then it will be somewhat easy to get the master changes into that branch.
Yeah, and try to make some changes into the master too, just to make it more adaptable. Just to make the change set as small as possible. And there's we don't have. I don't have a really good idea on how to do this in the modular way.
Yeah, no. I just want to mention in case you or James was like, oh, you just do yada yada yada.
Yeah. Maybe James do have a math something, but he just went to dinner. Okay, so I have this thing, 5 points to take on. ELB Pesto has to have persistence storage. Threshold threshold thing you are going to add, user agent porting, and the two-factor gateway. That's the components we need to do. Look at the list. It's actually a lot.
Yeah, it's it's not that easy to to roll such a solution.
Yeah. Yeah. Okay. Anyway, I hope yeah, I hope it goes smooth. Okay, I'll send you this, the whatever I noted down.
All right. All right. Thank you.
Thank you, everybody. Is Sunil here? Still here? No, he's not here. So maybe I ask him to come up online, because we are starting the virtual drinking, and everybody can everybody can stay online. I'm going to change to a tablet computer and grab a drink.
All right. Have a good one, guys. See ya. Bye.
Thanks. Bye.